to see the tangent theorem. Tangent theorem. A tangent at any point of a circle is perpendicular to the radius at the point of contact. Means what? Here we are going to prove that the radius drawn from point of contact is perpendicular to the tangent drawn from that point of contact. Now what is meant by point of contact? The point which is common in the circle and the line. That point is known as point of contact, and the segment joining center of the circle to the point of contact is known as radius drawn from point of contact. And here tangent theorem means what? We will prove that the radius drawn from point of contact is perpendicular to the tangent. Now, this theorem can be proved by indirect method. Now, first we will see what is meant by indirect method. Okay, indirect method. For example, suppose angle A and angle B are supplementary angles. That we have to prove. Angle A and angle B are supplementary angles. If we have to prove this statement by indirect method, then first I will consider that A plus B is greater than A 180 degree, A plus B is less than 180 degree, and A plus B is equal to 180 degree. Now, what is meant by indirect method? In indirect method, if I have to prove that A plus B is 180 degree, then I will prove that A plus B is greater than 180 degree or A plus B is less than 180 degree. These are the wrong assumptions, and hence A plus B is equal to 180 degree is the correct statement. This method is known as indirect method. I need duster. Okay. Now we will prove this theorem by indirect method. Now here what we have to prove? OA is the perpendicular. OA is perpendicular, but instead of OA I will assume that OA is not perpendicular to the line L. Instead of OA, segment OB is the perpendicular. Now on line N, LB is present because I have considered that OB is perpendicular to line L. Point A is already present because it is given. Now I will take one more point on line L, point C. How? Where? AB will be equal to BC. I will take this point C in such a way that AB is equal to BC. Now see here, I will draw two triangles and we will show that these two triangles are congruent triangles. How? Angle B is a right angle, B is a right angle. Now AB is equal to BC, that I have taken point C. OB is the common side, and hence it is proved that triangle OBA is congruent to triangle OBC by SAS test. Okay. Now, if these two triangles are congruent by SAS test, so remaining corresponding sides and corresponding angles are congruent. So, what happens here? Here the result is OA is equal to OC, corresponding sides of congruent triangles. OA is equal to OC. Now, what is OA? It is the radius of the circle. It is the radius of the circle. Okay. Radius OA. If OA is equal to OC means what? OA and OC are the radii. किंवा OA is the radius. सोपं statement. OA is the radius OC is also radius. Therefore, if OA and OC is also radius because OA is congruent to OC. Means what? The line L is passing through the point C also. But it is not possible because according to the definition of the tangent, tangent is a line passing through the exterior of the circle and one and only one point is common in between circle and the line. Then that line is known as tangent. If here result is that OA is equal to OC means point A is present on the circle, point C is also present on the circle and tangent is passing through the point A and point C. It is not possible. So, to consider that OA is not perpendicular to the line L is a wrong assumption. Here we have considered that OB is perpendicular to line L and then what we are getting here? Two different points A and C and tangent is passing through the, we know that tangent can be passed through the one and only one point. Then how it is possible that there are two different points are present A and C? Means what? To consider that instead of OA another segment is perpendicular to the line L is totally wrong assumption. So what is the right assumption? I can't say that this is the assumption. So what is the right statement? OA is the perpendicular to the L is the right statement. Hence it is proved that the radius drawn from point of contact is perpendicular to the tangent.